Okay, so we're going to continue talking about acids and bases, and we're going to summarize the electrolytic behavior of solutions, which are mixtures that are something, aqueous solutions, which are mixtures of two things, something dissolved in water. So all ionic substances that are soluble are strong electrolytes. So all soluble ionic substances are going to be strong electrolytes. Are any ionic substances going to be weak electrolytes? Well, we just said if it's soluble, if it's an ionic substance and it's soluble, it's strong. However, there are some ionic substances, as we know, that are insoluble. And so if it's insoluble, then, and it's ionic, then it will be a weak electrolyte. Let's see, an example. An example is lead iodide. If you looked on your solubility table, your rules, you would see that lead iodide is insoluble. It stays as a solid. Now, but a few leads and a few iodines will be floating around as ions, even though most of it will be a solid, and so that's why it will be a weak electrolyte. Could be very weak, could be mildly weak. So this table down here that I have, this is for just soluble ionic substances, but here, and that's why it says none, but here we're talking about insoluble ionic substance would be weak electrolytes. Ionic substances, there are none that are non-electrolytes. Now let's think about molecular substances. Strong acids, an acid is a molecular substance. A strong acid is going to be a strong electrolyte. Weak acids and weak bases, they will be weak electrolytes because they don't dissociate completely, but they do dissociate a little bit. And in order to be an electrolyte, you need to have an ion of some sort floating around in the water. So let's practice. We're going to classify these dissolved substances as strong electrolytes, weak electrolytes, or non-electrolytes. The first one is calcium chloride. So in order to decide if that's a strong electrolyte, weak, or not at all, first we have to decide what is it. Well, calcium chloride is ionic. I'm going to look on my solubility rules. I see here chlorides are always soluble unless they have these things in, but this is calcium chloride. So calcium chloride is soluble. And if it's soluble and it's ionic, whoops, that didn't work out so well, it's going to be a strong electrolyte. So this is strong. Okay, the next one is, doing a different color, HNO3. Now if you remember from your table of strong acids, this is nitric acid, so this is a strong acid. And all strong acids, oh I can't write anymore, all strong acids break up completely. So therefore, if they break up completely, they're going to be a strong electrolyte. So this is strong as well. The next one is ethanol, C2H5OH. We haven't really talked about, we talked very briefly about this last year, but this is an organic compound. It's molecular, it's not ionic. You have carbon and hydrogen, so there's no, this is not a binary ionic compound. There's no polyatomic ions here. So this is molecular, and you need to start recognizing that when you see carbon and hydrogen and oxygen, that's going to be an organic compound, and organic compounds are molecular. They're held together by covalent bonds. So this is a molecular compound. It's not an acid or a base, so therefore we're going to classify it as a non-electrolyte. It should not conduct electricity at all. The next one we have here, formic acid. Let me go back to red. HCOOH. The acid that should be, the proton that should be donated here is this first one. But that's not important right now. So this is an acid. This is not on our list of strong acids. That means this is a weak acid. And a weak acid is going to be a weak electrolyte. And finally, we have KOH. KOH is a base. We see the hydroxide there. And potassium is a group 1 metal. So any hydroxide with a group 1 metal is a strong base. And all strong bases are going to dissociate completely, so this will be a strong electrolyte because all of the ions will have dissociated and be free in the water to carry a charge. So that's how we can apply what we've learned to classifying things as strong or weak or non-electrolytes.